Okay, so hello again for another challenge. So this time we'll tackle Oski Lab from CyberDefenders.org. So this is a threat intel CTF type of challenge. So as we can see here, the initial tools or the only tools or the core tools that we'll be using are just OSINT tools or sandbox like VirusTotal and AnyRun. So again, we're not violating anything here. This is a retired challenge. So with that out of the way, let's move on to the scenario. So the accountant at the company received an email titled Urgent New Order. Okay, so there's a sense of urgency, as with any phishing email, from a client late in the afternoon. When he attempted to access the attached invoice, he discovered it contained false order information. Subsequently, the SIM solution generated an alert downloading a potentially malicious file, and upon initial investigation, it was found out the PPT file might be responsible for this download. Now we are asked to investigate it, and here are the key questions. So again, the file here, they gave a file here. So what we can do here is, excuse me. Yeah, I've downloaded it already here, Oski, and upon extracting it, you have to use the password cyberdefenders.org. And the content of that file is actually just a hash.txt file, which contains this file. Uh, let, this is the content of that file. Okay, so we will be using mainly VirusTotal and AnyRun for this. So let's do that. Let's prepare our OSINT, and okay, that's a lot of hits and AnyRun. AnyRun. Okay, I think there's a guess here. Submit. Okay, maybe let's try another one. Okay, there you go. 1, 2, C. What I did is just a combination of keywords, AnyRun, and a result for this hash. And as you can see here, already have a result for that. There's already a public analysis of that file. So if we search again for that hash, you can see that's the MD5. Okay, now that's done. Let's go back. Oh, this is not the challenge. That's the previous one. Okay, determining the creation time of the malware, which can provide insights. Or what was the time of the malware creation? Okay, so VirusTotal submissions help us get that metadata. So we can see here the creation time. Okay, here it is actually. So is it just the date that's been asked? Oh, it's even the hour and the hour up to the minutes. So 1740. All right, that's our first question. Okay, second one, identifying the command and control server that the malware communicates with can help trace back to the attacker. So which C2 server does the malware in the PPT file communicate with? So again, you have to know how to use VirusTotal. There are actually a lot of things that we can see here. The details tab mainly contain its metadata, the file or binary metadata, while the other tab like the relations can show you what the file is trying to do. So again, for the question, what C2 is it trying to connect to? You can see here it's trying to connect to this IP, contacted URL. So you could hover over the information there. So contacted URLs from the file being studied. Even the contacted domains is also the same. Alright, so we're being asked for the URL, and it has a hint here. is trying to download the .php. So do we have a .php here? Okay. So most likely this is that file. So we can copy this. So as you can see, it's a power up OSINT alone. We're not even touching the actual file itself. We're just actually inspecting the hash. So that's the power of the threat intel analysis and the community as well, because most likely the malicious file you've encountered, it's not the first time it was seen across all the environments in the world. Yeah, so oftentimes you'll be dealing with a reuse attack or reuse malware. Of course, not unless if it's really a targeted APT attacks. Of course, you'll be the first or you'll be the sole target. But that's besides the point. Okay. So question 3, identifying the initial actions to the malware post-infection can provide insights into its primary objectives. What is the first library that the malware requests post-infection? Okay, so going back again to the Relations tab. Okay, so what is the first library? So for every binary, so it's a bit of a malware or executable 101. Each executable that exe normally uses DLLs, combination of DLLs for its functionalities. So of course, for the benign binaries, they reuse the built-in Microsoft DLLs. But for the case of malicious executables, that exe files or any executable, they actually import their own malicious uh, DLLs. They import their own malicious. So that's what we are looking for. Let's see here if it's a SANate. Of course, um, known Microsoft DLLs are, even though they have the legit functionalities, they are often abused as well by malwares. Okay, let's see here. What is that DLL? Mm. Actually, for that, we can actually see the loaded DLLs I believe it's in Behavior tab. Execution. Yeah, somewhere here there's a exports or imports. Yeah, this one. Files drop. Okay, there's a DLL here. Yeah, we're looking for the first library that the malware requests post-infection. Alright, files drop. So let's see here. DLL. Yeah, request. The thing is, the first library the malware requests. So it requests from the C2 server. So as you can see here, it's the first request. So the SQLite that DLL. Oh, what happened? Let's search for that again. SQLite 3.dll. Okay. I hope you follow that. So next thing is number 4. By examining the provided end-run report, what RC4 key is used by the malware to decrypt its base64 encoded string? Okay, now we go to the end-run. Okay, what RC4 is used to decrypt base64 string? Okay, let's see here for a bit. RC4. Threats. Then RC4 decryption here. Maybe in the HTTP request. Okay. Okay, what we can begin from here. Okay, this is the process tree. Okay, this is the process tree. Verfold. Can we see any decryption here? Yeah, we can see the command line as well if you go to every process. But I don't think there's. Okay. What's the question again? Let's see if we can gain some hints. Okay, it's in the malware configuration. Check the malware configuration section of the encryption keys. Okay, let's go back. How do we get back to the reports? Check the malware configuration section for the encryption keys. Malware configuration section. Okay, how do we find that? Maybe it's okay. I think it's pointing to another URL. Let's see. Oh, yeah, it is indeed it is. This is a different AnyRun public result. So there's a malware configuration here. Yeah, this one. As you can see here, this is the RC4. Okay. So yeah, it's looking into another report. So yeah. So this is the string we're looking for. Okay. By examining the MITRE attack techniques displayed in the sandbox, identify the main MITRE technique used to steal the user's password. Okay, so there are MITRE section here. Steal, malware configuration, VPN. Malware command and control. Okay, there's actually a MITRE here. Full report. Okay, let's try open the full report. Okay, this is the. Where can we find that MITRE? MITRE mapping. Right, no MITRE mapping. Okay, let's try to ask for hints. Where can we find that? Review the techniques related. Review the techniques session. Okay, let's try this again. Is it looking at the same report? Okay, it's a good refresher actually. So it says here, review the MITRE with the bpn.exe. bpn.exe. Okay, there's a lot. If you click it, oh, okay, credentials from files. Oh, these are, if you click on any process, it shows you the process details and it has a MITRE mapping for that. So we're actually looking for process used for credentials from password stores. Credentials from password stores. Okay, maybe we'll try password stores. Maybe stores. Maybe it's somewhere here. 15. Is it looking for the MITRE? Oh yeah, it's looking for the MITRE number. So it will be, let's try 1055, 1555.003. 1555.003. Yeah, it's wrong because it's not, it's from web browser. So how about from password stores? Right, just trying to find where can we find where can we see that credential from password stores. It's always from browser. Or maybe we do not need to include the dot dot. Still wrong? Okay, where can we find that? Maybe in the other report. Oh, where is that other report? It's all the same. Oh, there's no MITRE here. Hmm. Okay, I guess we have to find it one by one, every process. Malicious, IOC. Yeah, I need to. Okay, I wonder where can I find that. Okay, let's go back. Oh, there. Okay, it shows us the matrix. So this is the credential from password stores. Alright, this VPN. So this is it. 1555. T1555. Yeah, I think you're just missing the T. Okay, there you go. Alright. Okay, question 6. By examining the child processes displayed, which directory does the malware target for the deletion of the LL files? Which directory? Okay. Which directory does the malware target? Let's go back. Uh, Maybe we can see it in the this one. There's actually delete files deleted here. Here, there's files deleted. So let's try that. Going back to the virus total result. Okay, so by the way, this is still under the behavior tab. Okay, it's asking for the files directory. That's the malware target for the deletion of the DLL files. Okay, maybe let's try this. Oh, of course, it's from any sandbox and delete. Okay, I think it's still referring to the, yeah, based on the hints. Okay, I think it's still referring to the, yeah, to the any run report. Let's go back. Locate the CMD process associated with the malware, which is the bpn.exe. So for the bpn.exe, yeah, okay. So this one, as you can see here, there's a del command here. So this is directory. So this is the directory it's looking for. C users admin updata local temp. Okay, let's try that. C users admin. Okay, if not, let's try to remove the executable. Malware target for the deletion of all DLL, of all DLL files. All, okay. User, it has okay, I missed that. It has additional command, so it's trying to delete all DLL here. So the path is C program data. Okay, I think I misunderstood the question. So this is the one it's looking for. Let's make sure the syntax is correct. Okay, submit. There you go. And finally, for the last question, understanding malware's behavior post-data exfiltration can give insights into its evasion techniques by analyzing the child processes. After successfully exfiltrating the user's data, how many seconds does it take for the malware to self-delete? Okay, I think we could also see it here. Self-delete. So actually there's /t here, so there's a time delay here. Yeah, we could gain some info as well from the 5 seconds. Is it looking for a maybe 5? It's just looking for a 1 digit here. Yeah, it's correct. It's a time. It's the delay timer of 5 seconds, as we see here in the command line. All right, and that does it. So yeah, hope you learned a lot. So I have to use a couple of hints. Yeah, but eventually we made it, right? So yeah. So please do it at your own as well, and yeah, don't be afraid to explore. But the thing is, there's really an art. It's really an art or an art to look into any sandbox report or OSINT report. Of course, you have to do correlation, not take it at face value. To, to to strengthen your case or to really uh, dig deep on the context of the incident. So yeah, that's it. Thank you very much. I'll see you on the next challenge. All right.